So another way to talk about dissociation energy is simply to call it bond strength. It's the same thing. They're equal to each other. If we know that this is the dissociation energy for a hydrogen atom, we can also say the bond strength for hydrogen molecule is 424. So there's actually another way to graph it where we can directly graph the dissociation energy or the bond strengths. So I said before when we were talking about single atoms, we always define the zero energy as when an electron was actually ejected. But now when we talk about chemical reactions taking place, it's very, very rare that we're actually going to be talking about anything that gets to this point here. It's much more relevant to set our 0 point energy as the separation of a bond in terms of talking about the reactions that we'll usually be dealing with here. So let's change our graph where we now have this 0 point set as the two individual hydrogen atoms, and then we see that our H2 molecule is at the negative of the dissociation energy, or the negative of what that bond strength is. So we know what that number would be. It would be negative 424 kilojoules per mole that we see here. So what this lets us do now is directly compare, for example, the strength of a bond in terms of a hydrogen atom and a hydrogen molecule compared to any kind of molecule that we want to graph on top of it. So let's, for example, look at nitrogen. So N2, we can do the chart here in green, so it's the green dotted line. And what we see is that we have now defined this energy as where the two nitrogen atoms are separated. So what we can actually directly compare is the dissociation energy or the bond strength of nitrogen versus hydrogen. So if we think about this, which would you say has the stronger bond? Is it going to be hydrogen or nitrogen? Yep, it's going to be nitrogen. And the reason we can see that by looking at this graph is that we see that nitrogen, when it's bonded, is in an even lower well than we saw for hydrogen. It's going to be a stronger bond because it's more stabilized when it comes together as a molecule. We can also think about the distance, the bond distance. So which would you say is going to be shorter in this case? Is a hydrogen bond shorter, or is a nitrogen-nitrogen triple bond going to be shorter? Again, we can get this information directly from our graph. We see that the radius is shorter, so that means that the nitrogen-nitrogen bond is going to be shorter. We could know this information even if we just knew that the bond was stronger. We wouldn't need to look at a graph here, because it turns out that if you have a stronger bond, that also means that you have a shorter bond. Those two are correlated. And something that we'll see later on is that triple bonds, for example, are going to be stronger than a corresponding double bond or a corresponding single bond. So if we talked about a nitrogen-nitrogen single versus double versus triple bond, the triple bond will be the shortest and it will be the strongest.